Okay, so Chapter 9-5, Graph Quadratic Equations Using the Axis of Symmetry. Today's lesson is different from last lesson because we will be looking at equations that have a x and an x squared. And it's important that we understand the axis of symmetry in order to be able to graph these types of situations. So first I'd like to go over again the different parts of a quadratic equation, the parts of the graph, the parabola. First, we have the axis of symmetry, which is often shown using a dotted line to represent how you could fold in half the parabola and have both sides be exactly the same. Then we have the vertex, which is either the highest or the lowest point on the parabola, and it is on the axis of symmetry. Finally, we have the y-intercept, which is the place where the parabola crosses the y-axis. And this is going to be one of your favorite things, the quickest and easiest part about this graphing. On the other part of the paper that I passed out to you are the steps for graphing. Make sure as you're going through this lesson today that you fill out all the different pieces as I explain them in the video. So first, we're going to graph together an example, going through all the steps. The first example is y equals negative 3x squared plus 12x minus 5. The first thing that we always need to do is find the axis of symmetry. And the axis of symmetry, as shown in the steps, is found using the formula negative b over 2a. So when I find the axis of symmetry here, x is going to equal negative 12 over 2 times negative 3. And the b and the a and all that I'm talking about here, this is the a, this is the b, and this is the c. Okay, so we're going to simplify that fraction. We got two negatives, so it's going to mean it's positive 12 over 6, which simplifies to 2. I need to draw a dotted line representing the axis of symmetry at x equals 2. Alright, now I need to find the vertex. I'm going to take what I found x to be, and I'm going to plug it into the original equation to find out what y is. Y equals negative 3 times 2 squared plus 12 times 2 minus 5. Do the math there and simplify all that. You can use your calculator and you will find that y equals 7. So the vertex is at the point 2, 7. 2 coming from the axis of symmetry. Y coming from solving for y by plugging in 2. So our vertex is going to be at 2, 1, 2, 3, 4, 5, 6, 7. Next, we're looking for the y-intercept. The y-intercept, as it says in the steps, is always going to be 0, c. And in this case, c is negative 5. So I'm going to cross the y-axis at negative 5. Now, 1, 2, 3, 4, 5. That point right there, if I fold at the axis of symmetry, should be exactly the same distance from the axis on the other side. So I've got 1, 2 boxes, 1, 2 boxes. So I have a dot on the other side of the axis of symmetry, the same distance from the y-intercept. Now, as we're going through this, you should fill in the points that you found in the table that I've created for you. So we've got 2, 7, 0, negative 5. The point that I just put on there is 1, 2, 3, 4, negative 5. And now I need to find one more. What does that mean? Well, if I look at the graph, I want to know more about the curve, how wide it is, where it crosses the x-axis, etc. So when I'm looking at this graph here, I'm thinking, what values have I already used for x? I've used 0, I've used 2, and I've used 4, as you can see from our table. So I want to pick a value for x that I haven't chosen yet. So what about 1? I could use 1. So I'm going to plug in to my original equation a 1 instead of x. And I'm going to simplify it to find y, which is 4. I'm going to put it on my graph, 1, 4. And again, I'm going to fold my parabola in half, reflecting it across the axis of symmetry, duplicating the distance. Final step is to connect those dots with a nice smooth curve. Remember, no V's, we want U's. What a beautiful graph we have here. And that one more point was at 3, 4. Alright, so why don't you try the next one on your own and then see how you did. So the axis of symmetry is going to be x equals negative 4 over 2 times 2, which is negative 4 over 4, which is negative 1. So the axis of symmetry is through x equals negative 1. Always put your information on your graph as soon as you find it. Then we're going to look for the vertex. Remember, you're taking the x value and you're plugging it into the original equation to find out what y will equal. That gives me a y of negative 5. So my first point is at negative 1, negative 5. My vertex is 1, 2, 3, 4, 5, right there. Then the y-intercept is 0, c, 0, negative 3, and that would be right there. 0, negative 3, reflect it across the axis. It's going to be right there at negative 2, negative 3. And we need to find one more point. Think about the x values we've already used. We've already used negative 2, negative 1, and 0. An easy one would be to use x equals 1. So let's plug in a 1 into our original equation and solve for y, which gives us 3. So I have the value 1, 3. So on my graph at 1, 3. That's 2 spaces away from the axis of symmetry. 2 spaces away from the axis of symmetry. Connect it together with a nice smooth U-shaped curve. Let's do one more example. Again, try to do this on your own, then check. So in this equation, my a is 1. So x equals negative 4 divided by 2 over 1. It's that invisible 1. And that simplifies to a negative 2. So I've got an axis of symmetry going through negative 2. Substitute it in to find the vertex. That gives me negative 2 squared plus 4 times negative 2 plus 2. That simplifies to a y of negative 2, so my vertex is at negative 2, negative 2, which should be right there. The y-intercept is 0, c. 0, 2. That's 2 spaces from my axis of symmetry, 2 spaces on the other side. That's right there. Now I need to find one more point. 0, 2, -4, 2. So looking at my x values, I could try a -1. Plugging in a -1, I've got -1 squared plus 4 times -1 plus 2. Remember, these parentheses are really important, especially if you're using your calculator to solve it. So at -1, -1, I have another point. Whoops, let's put that on the graph. -1, -1. That's one space from the axis of symmetry, so one space. Connect it with a nice smooth curve. Hopefully this is making sense to you guys and you're doing really well with it. Just keep track of the steps and always graph every little piece as you go. Why don't you do some more practice? Remember, show your work. That means I want you to graph it by hand first, then on the computer to check your work. I will be checking these.